Hello, dear friends, and welcome to the Bedtime Lab. I'm so glad you've decided to join me tonight. Here, we cherish those quiet moments just before sleep, where curiosity meets serenity. Tonight, let's journey through the stars and explore the fascinating world of space medicine research together. As you get cozy, feel free to share where you're tuning in from in the comments below. It's always wonderful to know where our community of fellow dreamers is nestled around the globe. Now, let me share something interesting about space medicine. Did you know that one of the earliest concerns for astronauts was how their hearts would function in the weightless environment of space? Our hearts, so used to working against gravity, change shape in space, becoming more spherical. This can have various effects on how blood is pumped, and scientists are continually studying these changes to help keep astronauts healthy during their missions. Speaking of heart changes, here's another fascinating fact. Astronauts can actually grow taller in space. Without the compression of gravity, their spines can elongate, typically adding around 2 inches to their height. Can you imagine that? Growing taller just by floating in space. It's like magic, but it's just the wonders of our universe at play. Now, let's think about the eyes for a moment. Did you know that spending time in space can affect vision? Many astronauts experience changes in their vision, a condition known as spaceflight-associated neuroocular syndrome. It's caused by fluid shifts in the body, and researchers are working tirelessly to understand and mitigate these effects to ensure space travelers can see clearly, both in space and when they return home. And here's something truly surprising. Space medicine research isn't just about keeping astronauts safe, it also benefits us right here on Earth. For example, the study of muscle atrophy in space has led to better treatments for muscle-wasting diseases on Earth. This is a beautiful reminder of how interconnected our lives are with the cosmos. You might be wondering about the impact of microgravity on bones. In space, bones lose minerals at an accelerated rate, similar to osteoporosis here on Earth. Researchers have been developing strategies to counteract this, which in turn enhances our understanding of bone health and treatments for related conditions. Speaking of health, did you know that astronauts have to stay in top condition even before they leave Earth? They undergo rigorous training and health monitoring to ensure they're ready for the challenges of spaceflight. This reminds us of the incredible commitment and resilience of those who venture beyond our planet. And here's something you might not expect. Space has an impact on the immune system. Studies have shown that microgravity can weaken the immune response, making astronauts more susceptible to infections. This has led to advancements in our understanding of the immune system, benefiting medical research on Earth. Now, let's consider sleep, a topic close to our hearts here at the Bedtime Lab. You may be surprised to learn that sleeping in space can be quite different from sleeping on Earth. Without the natural cycle of day and night, astronauts must rely on artificial lighting to regulate their sleep patterns. This research has contributed to a deeper understanding of sleep disorders and how to address them. And speaking of artificial environments, did you know that the air quality in a spacecraft is meticulously controlled? Scientists have developed advanced systems to filter and recycle air, ensuring astronauts breathe comfortably. These innovations have also led to improvements in air purification technologies we use in our homes. Another intriguing aspect of space medicine is the psychological well-being of astronauts. Isolation and confinement can take a toll on mental health, so space agencies prioritize psychological support, which has furthered the development of strategies to support mental health in remote or isolated environments on Earth. Here's something that might bring a smile. Space medicine research also studies the effects of laughter and humor in space. Laughter has proven benefits for mental health and stress relief, which are crucial for maintaining morale during long missions. And finally, did you know that as we look towards future missions to Mars and beyond, space medicine will play a critical role? Researchers are already planning how to address the unique challenges of prolonged space travel, ensuring astronauts stay healthy on journeys that could last years. I hope these facts have sparked your imagination as you drift off to sleep. Imagine the endless possibilities as we continue to explore the cosmos, bringing back knowledge that touches every aspect of life on Earth. Thank you for joining me on this journey tonight. May your dreams be filled with stars and the gentle mysteries of the universe. Sleep well, dear friends. Until next time, as you settle deeper into your cozy spot, let's delve into more of the wonders of space medicine. Consider this: the effects of space travel on the human body are not just immediate, but can be long-lasting. For instance, did you know that some astronauts report changes in their sense of taste during missions? Foods that once seemed flavorful might become bland or even metallic tasting in the microgravity environment. Researchers suggest that shifts in fluid distribution could be the cause, possibly altering the way we perceive flavors. This fascinating phenomenon highlights how adaptable, yet strangely vulnerable, our senses can be to new environments. Now, let's explore the intriguing world of spacesuits. These incredible garments are more than just protective layers. They function as personal life support systems. Spacesuits must regulate temperature, provide a breathable atmosphere, and offer protection from micrometeoroids. One surprising aspect is how they are tailored to individual astronauts. Each suit is custom-fitted to ensure maximum comfort and mobility, allowing astronauts to conduct their tasks without unnecessary hindrance. It's like having your very own high-tech cocoon in the vastness of space. Speaking of clothing, did you know that astronauts' clothes are designed to be disposable? Without laundry facilities aboard a spacecraft, garments are worn and then jettisoned once they become too soiled. Researchers are examining ways to create more sustainable clothing options, which could also benefit us on Earth by inspiring advances in textile technology. As we think of long journeys, consider the role of nutrition in keeping astronauts healthy. Space food has evolved significantly from the early days of pureed meals in tubes. Today, astronauts enjoy a variety of foods, from fruits and nuts to more complex dishes. But here's an interesting fact. Because of bone density loss in space, it's crucial for their diets to be rich in calcium and vitamin D. These nutritional insights have not only improved space travel meals, but have also contributed to better understanding of dietary requirements for bone health on Earth. Now, imagine trying to exercise in a place where you constantly float. Surprisingly, astronauts spend about 2 hours daily working out to counteract muscle and bone loss caused by weightlessness. These workouts include resistance training, treadmill running, and cycling, all specially adapted for a zero-gravity environment. This rigorous regimen has provided valuable insights into how exercise can be optimized, not only for those in orbit, but also for individuals on Earth recovering from injury or illness. While we're on the topic of adaptation, let's talk about how astronauts adapt to the confined spaces of a spacecraft. This limited space requires careful organization and efficient use of every inch available. Did you know that the International Space Station is equipped with sleeping pods, where astronauts can secure themselves with sleeping bags to avoid floating around? Learning to live in such close quarters enhances our understanding of human behavior, and has applications in designing small, efficient living spaces here on Earth.
What about the fascinating issue of water?
In space, water is a precious commodity, and astronauts can't simply turn on a tap. Instead, they rely on recycling systems that purify and reuse water from various sources, including humidity collected from the air and even urine. These sophisticated systems have advanced our water purification technologies on Earth, ensuring more efficient use of this vital resource. As we consider the extraordinary challenges of space, did you know that researchers study the effects of radiation exposure during space travel? Space is filled with cosmic rays and solar radiation that can pose significant health risks. Understanding how to protect against these hazards not only safeguards astronauts, but also contributes to developing better protective measures against radiation exposure on Earth, such as for medical imaging procedures. Here's something you might find surprising: the study of how wounds heal in space. In microgravity, cells behave differently, which can affect the healing process. This research has profound implications for improving medical treatments and wound care on Earth, offering hope for faster recovery times and better outcomes. While pondering the vastness of space, let's not forget the importance of communication. Maintaining contact with Earth is crucial for astronauts' psychological well-being and operational success. Interestingly, the technology developed for space communication has also paved the way for advancements in telecommunications on Earth. As we drift through these facts, imagine the resilience required by those who venture beyond our planet. The knowledge gained from their journeys extends far beyond the boundaries of space, touching on aspects of health, technology, and human endurance. Each discovery in space medicine is a testament to human ingenuity and our unyielding desire to explore the unknown. As you close your eyes tonight, let these wonders of space medicine accompany you into a restful sleep, dreaming of the endless possibilities that await us among the stars. Let's continue our journey through the intriguing realm of space medicine. Have you ever considered how space travel affects the human immune system? It's fascinating to note that the stress of microgravity can actually weaken an astronaut's immune response. This occurs due to changes in white blood cell function, making astronauts more susceptible to infections. Studying these changes not only helps protect those in space, but also provides insights into autoimmune diseases and ways to bolster immune health on Earth. Speaking of health, did you know that researchers explore the psychological effects of space travel? The isolation and confinement of space missions can pose significant mental health challenges. Scientists have developed techniques to support astronauts' mental well-being, such as virtual reality environments that simulate nature scenes. These innovations are finding their way into therapeutic applications on Earth, offering new tools for managing stress and anxiety. Now let's delve into the complexities of bone health in space. In the absence of gravity, astronauts can lose up to 1% of their bone mass per month. This rapid bone density loss has prompted extensive research into osteoporosis and bone regrowth. The findings from these studies are contributing to novel treatments and preventative measures for bone health conditions here on Earth. You might find it intriguing that space research has led to advancements in cardiovascular health. Astronauts experience changes in heart shape due to fluid redistribution in microgravity. These observations have spurred studies into heart function and adaptation, leading to better diagnostic tools and treatments for heart conditions that affect many people worldwide. Speaking of the body, consider how space affects vision. Many astronauts report changes in their eyesight during and after space missions, known as spaceflight-associated neuroocular syndrome, or SANS. This condition involves swelling of the optic nerve and changes in vision acuity. Discovering how microgravity affects the eyes has opened new avenues for research into eye health and the prevention of vision loss in various populations. You might also be interested to know that space medicine has inspired innovations in surgery. The challenges of performing medical procedures in space have led to the development of robotic surgical tools. These tools enable more precise and less invasive surgeries, and their use is becoming increasingly common in hospitals on Earth. Have you ever wondered how astronauts maintain dental health in space? Without regular dental care facilities, astronauts rely on preventive measures and innovative tools to keep their teeth healthy. Research in this area has influenced advancements in dental care technologies, making dental hygiene more accessible and effective for remote and underserved communities. Speaking of hygiene, in the unique environment of space, researchers have also studied how the skin reacts to microgravity. Astronauts often experience changes in skin texture and sensitivity. This research is shedding light on skin conditions and leading to better skincare products that can help maintain healthy skin under diverse conditions. Now, let's talk about sleep, a crucial aspect of both space missions and life on Earth. The absence of a natural day-night cycle in space can disrupt an astronaut's sleep patterns. To combat this, scientists have developed specialized lighting schedules and sleep technologies that promote better rest. These innovations are being adapted to improve sleep quality for shift workers and those suffering from sleep disorders on Earth. Consider the fascinating topic of nutrition and how space travel has influenced food science. The need to preserve food in space has led to breakthroughs in packaging and preservation techniques, enhancing food safety and shelf life. These advancements are now improving food storage and distribution globally, helping to reduce waste and improve food security. Speaking of nutrition, space missions have also highlighted the importance of hydration. In a microgravity environment, the body's fluids shift, altering thirst perception. Understanding these changes has improved our knowledge of hydration strategies, benefiting athletes and individuals working in extreme environments on Earth. Now, let's ponder how space medicine has transformed our understanding of aging. The accelerated physical changes experienced by astronauts offer a unique model for studying aging processes. Insights gained from these studies are aiding in the development of interventions to promote healthy aging and longevity. You might not expect this, but space research is even influencing the field of pharmacology. The way drugs dissolve and are absorbed in microgravity differs from on Earth, leading to new formulations and delivery methods. These discoveries are enhancing the effectiveness of medications for various conditions, ensuring they work as intended regardless of environmental variables. Speaking of challenges, let's not forget the complexity of human reproduction in space. While not yet fully explored, early studies suggest that microgravity could impact reproductive health. As we consider the possibilities of long-term space habitation, understanding these effects will be crucial for the health of future generations. Imagine the potential of all these discoveries. Space medicine is not just about ensuring the health of astronauts. It's a gateway to understanding complex biological processes that touch every aspect of human life. From immune health to aging, each finding contributes to a broader understanding of how we can improve health and well-being here on Earth. As you drift off to sleep, let your mind wander through these possibilities, dreaming of a future where the lessons from space guide us towards a healthier, more connected world. Have you ever thought about how the body's immune system functions in space? In the microgravity environment, the immune response can become less effective, making astronauts more susceptible to infections. This intriguing phenomenon has prompted research into how space influences immune function, leading to new insights into autoimmune diseases and potential treatments here on Earth. Speaking of immunity, did you know that astronauts' microbiomes also change during space missions? The balance of bacteria in the body can shift, affecting digestion and overall health. This research into microbiome dynamics is enhancing our understanding of probiotics and gut health, with promising applications for improving digestive health and resilience to infections. Let me share something interesting about muscle health in space. Without the constant pull of gravity, astronauts experience muscle atrophy, or a decrease in muscle mass. To combat this, space agencies have developed specialized exercise regimens and equipment, such as resistance bands and treadmills. These innovations are inspiring new methods for rehabilitation and physical therapy, helping people recovering from injuries or surgeries to regain strength more effectively. And here's something fascinating about the study of circadian rhythms in space. The absence of natural light cues can disrupt an astronaut's internal clock, affecting their sleep-wake cycle, mood, and cognitive performance. By studying these effects, researchers are developing better strategies for managing jet lag and sleep disorders, including optimizing light exposure and timing to improve overall well-being. Can you imagine what it's like to maintain physical fitness in a confined space? Space missions require astronauts to stay in top physical condition despite the constraints of their environment. This challenge has led to the development of compact, multifunctional exercise equipment that can be used in small spaces. These innovations are making it easier for people living in urban areas with limited space to maintain a regular fitness routine. Speaking of adaptation, consider the effects of radiation exposure in space. Astronauts are exposed to higher levels of cosmic radiation, which can increase the risk of cancer and other health issues. This exposure is driving research into protective measures and treatments, including the development of materials and technologies to shield against radiation. These advancements are not only significant for space exploration, but also for improving radiation protection for those in high-risk professions on Earth. Here's a fascinating fact about how space travel influences metabolism. The unique environment can affect how the body processes nutrients, with potential impacts on weight management and metabolic health. By studying these changes, scientists are discovering new ways to optimize nutrition and metabolism, offering fresh perspectives on managing conditions like obesity and diabetes. Have you ever wondered how psychological resilience is built in the challenging conditions of space? The demands of long-duration missions require astronauts to develop exceptional coping skills. This has led to research into resilience training and mental health support, with applications for improving stress management and mental toughness in challenging environments on Earth, such as in the military or emergency services. Speaking of long missions, did you know that even the vestibular system, which helps maintain balance, is affected by space travel? The lack of gravity can cause dizziness and disorientation, a phenomenon that researchers are studying to better understand conditions like vertigo. This research is paving the way for new treatments and therapies to help people with balance disorders regain stability and confidence. Consider the intriguing study of genetic expression in space. Microgravity can alter gene expression, providing insights into how our genes respond to environmental changes. This research is contributing to the field of epigenetics, exploring how lifestyle and environmental factors can influence gene activity and potentially improve health outcomes for individuals. Let's not forget the importance of collaboration in space medicine research. International cooperation among space agencies and scientific institutions is driving forward groundbreaking discoveries. This collaborative spirit is not only advancing our understanding of space medicine, but also fostering global partnerships that are tackling health challenges on Earth, encouraging a more unified approach to medical research and innovation. Have you considered how space medicine might influence remote healthcare? With astronauts often isolated from direct medical care, telemedicine has become a vital component of space missions. The technologies and protocols developed for space are enhancing telehealth services, making quality healthcare more accessible to remote and underserved populations worldwide. On the topic of telemedicine, did you know that space research has contributed to the development of advanced imaging technologies? The need for reliable diagnostic tools in space has led to innovations in portable imaging devices, such as ultrasound machines. These advancements are empowering healthcare providers with better diagnostic capabilities in challenging or resource-limited settings. Speaking of diagnostics, consider how space medicine is enhancing our understanding of chronic pain management. The unique stresses of space missions have led to research into pain perception and management techniques, fostering the development of novel approaches to alleviate chronic pain, improving quality of life for millions affected by this condition. Finally, let's reflect on the broader impact of space medicine research. As we continue to explore the cosmos, each discovery enriches our understanding of human health. The lessons learned in space medicine are helping to create a healthier, more sustainable future for all of us, bridging the gap between the unknowns of space and the challenges we face on Earth. As you drift into sleep, let your dreams be filled with the wonder of these possibilities, where the vastness of space meets the depths of human potential. Let me share something intriguing about the heart's behavior in space. Without gravity's pull, the heart doesn't have to work as hard to pump blood through the body, leading to a phenomenon where the heart muscle decreases in size. This fascinating adaptation has sparked interest in better understanding heart health and disease progression on Earth, offering new insights for managing conditions like heart failure. Shifting gears to the intriguing world of immune system research, did you know that space travel can alter an astronaut's immune response? The stress of spaceflight can weaken the immune system, making astronauts more susceptible to infections. By studying these changes, scientists are uncovering new ways to boost immunity and develop better vaccines, particularly important as we face global health challenges. Speaking of stress, isn't it interesting how the isolation and confinement experienced during space missions can mirror the psychological effects of lockdowns on Earth? Researchers are using this parallel to study the impacts of isolation on mental health, creating strategies to support well-being during prolonged periods of social distancing or isolation, enhancing resilience in both astronauts and those of us navigating unprecedented times on Earth. Have you ever wondered how astronauts deal with the challenge of maintaining eye health in space? The microgravity environment can cause changes in vision, a condition known as spaceflight-associated neuroocular syndrome. This has led to groundbreaking research into ocular health, which is shedding light on conditions such as glaucoma and macular degeneration, promising to improve eye care for everyone. Turning our attention to bone health, the lack of gravity in space causes bones to lose mineral density, similar to osteoporosis on Earth. Scientists are studying these effects to develop new treatments that can prevent bone loss, benefiting not only astronauts but also individuals suffering from bone degenerative diseases. And here's something you might find intriguing: the effects of space travel on gut health. In the unique conditions of space, the composition of gut microbiota can change, impacting digestion and immunity. This research is leading to innovative probiotics and dietary strategies aimed at nurturing a healthy gut, enhancing overall health and longevity. Speaking of nutrition, did you know that the food consumed in space is carefully studied to ensure it meets all nutritional needs? This research is paving the way for the development of fortified foods and supplements that can address malnutrition and dietary deficiencies here on Earth, helping improve public health in communities around the world. On a related note, consider the importance of hydration in space. Without gravity, fluids in the body can shift upwards, causing dehydration and other issues. Scientists are using these findings to develop new strategies for managing hydration levels, which can benefit athletes, elderly populations, and those living in hot climates. Taking a closer look at cognitive performance, the stress and confinement of space missions can affect an astronaut's ability to concentrate and make decisions. This has led to research into cognitive training programs designed to enhance mental performance, offering potential benefits for people in high-pressure jobs on Earth, such as air traffic controllers or surgeons. Have you heard about the fascinating ways space research is contributing to sleep technology? The unique sleep challenges faced by astronauts have inspired innovations in sleep aids and technology, such as advanced mattresses and smart sleep trackers, helping all of us achieve a better, more restful night's sleep. Let's explore the world of robotics, where space medicine research is making significant contributions. The development of robotic systems to assist astronauts in space is fueling advancements in robotic-assisted surgery and rehabilitation on Earth, improving precision and outcomes in medical procedures. Here's an intriguing fact about how space medicine is influencing the development of new materials. The need for durable and lightweight equipment in space has led to the creation of advanced materials with applications in prosthetics and orthopedic devices, enhancing mobility and quality of life for many. As we delve deeper into the effects of space on human physiology, consider the changes in blood flow and pressure experienced by astronauts. These changes are helping scientists understand cardiovascular diseases better, leading to improved diagnostic techniques and treatments for conditions like hypertension and atherosclerosis. Speaking of medical diagnostics, did you know that space research is enhancing non-invasive diagnostic methods? The limitations of space travel necessitate innovative approaches to monitor health, such as wearable sensors and remote diagnostics, which are revolutionizing preventive care and personalized medicine on Earth. Finally, let's reflect on the unique perspective that space medicine research brings to patient care on Earth. The challenges of providing medical care in space are inspiring new models of healthcare delivery, emphasizing efficiency and adaptability, which are crucial for advancing healthcare systems in both urban and remote regions. As you reflect on these insights, let your mind wander through the tapestry of space medicine's contributions, where each discovery builds bridges between the stars and the intricacies of human health. Let these thoughts carry you gently into a restful slumber, infused with the wonder and potential of the cosmos. As we continue our journey through the fascinating realm of space medicine, have you ever thought about how muscle health is maintained without gravity's constant presence? In the zero-gravity environment of space, muscles can weaken and atrophy more rapidly than on Earth. To combat this, astronauts engage in rigorous exercise routines, which are now informing new rehabilitation techniques and exercise regimens to help prevent muscle loss in patients on Earth and improve recovery after injury. This is especially beneficial for those who are bedridden or have limited mobility, providing them with tailored exercise programs that can help maintain their muscle strength. Speaking of muscle, Did you know that space travel can impact the body's metabolic processes in intriguing ways? Without gravity, the body's energy expenditure changes, leading researchers to study how metabolism adapts in space. This research is opening doors to new approaches for managing metabolic disorders, such as diabetes and obesity, by providing insights into how the body uses energy and stores fat. Such findings are invaluable in our quest to promote healthier lifestyles and manage weight more effectively. The adaptability of the human body in space leads us to another fascinating area, the vestibular system, which helps regulate our sense of balance and spatial orientation. In the absence of gravity, this system undergoes significant changes, offering valuable insights into balance disorders experienced by people on Earth. By understanding these changes, scientists are developing new therapies and techniques to treat conditions like vertigo and balance impairments, improving quality of life for many individuals. Imagine the challenges faced by an astronaut's skin in the harsh environment of space. Without gravity, changes in circulation and fluid distribution can affect skin health, leading to insights that are advancing dermatology. This research is guiding the development of new treatments for skin conditions such as eczema and psoriasis, as well as enhancing our understanding of the aging process, paving the way for innovative skincare solutions. Continuing with the theme of adaptability, let's delve into the fascinating world of genetic expression. Space travel can cause changes at the genetic level, altering the expression of certain genes. This research is shedding light on how environmental factors influence gene expression, potentially leading to breakthroughs in gene therapy and personalized medicine. By understanding these genetic changes, scientists can better tailor treatments to individual needs, improving the efficacy of medical interventions. Have you ever wondered about the mental resilience required for long-duration space missions? The psychological demands of space travel are immense, prompting research into stress management and emotional well-being. This has led to the development of innovative mental health strategies that are beneficial not only for astronauts, but also for individuals facing high-stress situations on Earth, such as first responders and military personnel. These strategies are helping people build resilience and cope more effectively with stress. In the realm of communication, space missions have spurred remarkable advancements in telemedicine. Providing healthcare over vast distances necessitates reliable and efficient communication technologies. These innovations are transforming how medical care is delivered in remote areas on Earth, ensuring that even the most isolated communities have access to healthcare services. This is particularly crucial in regions where medical resources are scarce, bridging the gap between patients and healthcare providers. Speaking of remote care, think about the role of artificial intelligence in space medicine. AI technologies are being developed to assist in diagnosing and treating medical conditions in space, where access to physicians is limited. These AI systems are now being adapted for use in hospitals and clinics on Earth, improving the speed and accuracy of diagnoses and enhancing patient care. By integrating AI into healthcare, we are moving towards a future where medical services are more accessible and efficient. The impact of space on human health extends to the realm of reproductive health as well. The effects of microgravity on reproduction are not yet fully understood, but research in this area is leading to new insights into fertility and reproductive health treatments. By studying reproductive processes in space, scientists aim to improve treatments for infertility and better understand reproductive health issues on Earth, offering hope to many who face challenges in conceiving. As you contemplate these remarkable connections, consider how space exploration is also driving advancements in the field of regenerative medicine. The unique conditions of space are being used to study stem cells and tissue regeneration, with the potential to revolutionize treatments for injuries and degenerative diseases. This research is paving the way for breakthroughs in healing damaged tissues and organs, offering new possibilities for patients with severe injuries or chronic conditions. Let us return to the captivating subject of radiation exposure. The increased radiation levels in space pose significant risks to astronauts, leading to extensive research on radiation protection. This research is crucial in developing protective technologies that can be applied on Earth, particularly for those working in high radiation environments, such as healthcare workers and nuclear industry employees, ensuring their safety and well-being. As we contemplate these vast research areas, consider how space medicine is expanding our understanding of human resilience and adaptability. The knowledge gained from studying the human body in space is setting the stage for innovations that enhance health and wellness on Earth. Let these reflections guide you to a deeper appreciation of the intricate connections between space exploration and medical advancement, as your thoughts gently drift towards a state of peaceful rest enveloped in the wonders of the universe. Let me share something intriguing. When astronauts return to Earth, they often experience a temporary reduction in bone density. This phenomenon is akin to osteoporosis and has driven research into treatments that could benefit those suffering from bone loss on Earth. By studying bone density changes in space, scientists are unlocking new strategies to maintain bone health as we age. This reminds me of an interesting observation about the immune system. In the microgravity environment, astronauts' immune responses can weaken, making them more susceptible to infections. This unique challenge is illuminating new ways to bolster immune defenses, potentially leading to improved vaccines and therapies for immune-related disorders on Earth. Speaking of systems that adapt, did you know that space travel can alter cardiovascular function? The heart and blood vessels adjust to the absence of gravity, affecting how blood circulates through the body. Researchers are exploring these changes to develop novel treatments for cardiovascular diseases, such as hypertension and heart failure. This line of inquiry is offering hope for millions of people who face cardiovascular challenges. Here's a fascinating insight. Space medicine is also shedding light on our circadian rhythms. The absence of a natural day-night cycle in space can disrupt sleep patterns, prompting scientists to examine how these rhythms can be better regulated. This research is aiding the development of sleep therapies that help those with insomnia and circadian rhythm disorders, promoting restorative rest and improved health. Can you imagine the challenges in monitoring astronaut health remotely? This necessity has driven advances in wearable health technology that can continuously track vital signs. These innovations are now being used on Earth, empowering individuals to manage chronic conditions more effectively and enabling healthcare professionals to intervene before a condition worsens. Similarly, the microgravity environment impacts fluid distribution in the body, leading to a phenomenon known as moon face, where facial tissues swell due to fluid shifts. This curious effect is helping scientists understand edema and fluid balance better, with implications for treating conditions like heart failure and lymphedema. Consider the intriguing influence of space on muscle physiology. Without regular exercise under gravity, astronauts experience muscle atrophy, similar to what occurs in sedentary individuals or those with limited mobility on Earth. Research into counteracting muscle loss in space is informing physical therapy and rehabilitation techniques that aid recovery and improve muscle function after injury or surgery. And here's another captivating fact. The study of plants in space has revealed surprising insights into how microgravity affects growth and development. These findings are enhancing agricultural practices on Earth, leading to more efficient and sustainable ways to grow food, even in challenging environments. Thinking about the auditory system, prolonged exposure to the noise of spacecraft can impact hearing. This has spurred research into hearing protection and conservation, benefiting those who work in noisy environments such as construction and music industries. By understanding and mitigating auditory risks, we can preserve hearing health for generations. Moreover, the study of wound healing in space has shown that microgravity can slow tissue repair. This unexpected discovery is guiding advancements in wound care and healing techniques, offering new hope for patients with chronic wounds or those recovering from surgeries. As we explore the intricacies of human health in space, consider the role of nutrition. Maintaining nutritional balance in space is crucial for astronaut health, and this focus has led to the development of nutrient-rich foods that support health and longevity on Earth. These advancements are particularly beneficial for populations facing nutritional deficits, ensuring access to vital nutrients. Speaking of access, imagine the logistical challenges of transporting medical supplies to space. This necessity has fueled innovations in medical supply management and delivery systems, improving the efficiency and accessibility of medical resources in remote areas on Earth. And here's something that might surprise you. The study of human microbiomes in space is revealing how microgravity influences the balance of beneficial bacteria in our bodies. These insights are driving breakthroughs in probiotics and gut health, contributing to better digestive health and overall well-being. In the realm of mental health, the isolation and confinement faced by astronauts have driven research into social support systems and coping strategies. These studies are benefiting those in remote or isolated environments on Earth, enhancing mental health support and community resilience. Lastly, let us consider the impact of space travel on vision. Many astronauts experience changes in vision due to fluid shifts that increase pressure on the eyes. This has led to valuable research on eye health and vision correction, providing new approaches to treating vision impairments. As we delve deeper into these fascinating aspects of space medicine, it's remarkable to see how the challenges of space travel are transforming healthcare on Earth. Through this shared knowledge, we gain a greater appreciation for our resilience and the boundless potential of medical innovation, all inspired by humanity's ventures beyond the stars. Let me share something truly remarkable about the effects of space on human biology. The study of telomeres. Telomeres are the protective caps at the end of our DNA strands, and they play a crucial role in cellular aging. In space, something unexpected happens. These telomeres actually lengthen. This surprising phenomenon provides unique insights into the aging process and has sparked discussions about potential anti-aging therapies. Imagine the possibilities if we could harness space-induced telomere changes to improve health and longevity on Earth. Another fascinating aspect is the impact of space travel on the vestibular system, which is responsible for balance and spatial orientation. In microgravity, astronauts often experience a sense of disorientation, sometimes referred to as space motion sickness. By studying these effects, scientists are learning how to better manage balance disorders on Earth, potentially offering relief to those with inner ear issues or vertigo. Speaking of adaptations, let's consider how spaceflight influences cellular regeneration. Did you know that in microgravity, the body's ability to regenerate cells can be altered? This has led to groundbreaking research into stem cell therapy and tissue engineering. These advancements may one day improve treatments for a range of diseases, from degenerative conditions to traumatic injuries. And here's something intriguing about the role of stress in space. Astronauts face unique stressors in the form of isolation, confinement, and the inherent risks of space travel. Studying their stress responses is helping scientists develop better strategies for stress management and resilience, which are invaluable for high-pressure professions and everyday life on Earth. The next topic may sound like science fiction, but it's very real: bioprinting in space. The absence of gravity allows for the printing of more complex three-dimensional tissues and organs without the constraints found on Earth. This innovative approach holds tremendous potential for organ transplantation and regenerative medicine, offering hope to countless patients awaiting vital medical interventions. Additionally, space travel has unveiled insights into genetic expression. Microgravity can alter the way certain genes are expressed, leading to changes in cellular function. This research is shedding light on genetic regulation and epigenetics, potentially paving the way for personalized medicine and targeted therapies for genetic disorders. Now, let's ponder the psychological aspects of long-duration space missions. The challenges of living in confined quarters for extended periods have prompted studies into the effects of social isolation and group dynamics. These insights are informing practices to enhance team performance and mental well-being in various settings, from remote research stations to submarines. On a similarly fascinating note, the absence of gravity affects the structure and function of the spine. Astronauts often grow taller in space as spinal discs expand. This has led to a deeper understanding of spinal health and could influence treatments for back pain and spinal conditions on Earth, offering relief to millions who suffer from these ailments. Consider the intriguing relationship between space travel and metabolism. In the microgravity environment, astronauts' metabolic rates can change, influencing how their bodies process nutrients and energy. This research is unlocking new approaches to managing metabolic disorders and obesity, contributing to more effective dietary guidelines and interventions. Speaking of nutrition, let's discuss the challenge of food preservation in space. Without refrigeration, astronauts rely on food that has been carefully processed and preserved. Innovations in food technology developed for space missions are now being applied to improve food safety and shelf life on Earth, benefiting areas prone to food insecurity and spoilage. Interestingly, space medicine research is also advancing our understanding of radiation exposure. In space, astronauts are exposed to higher levels of cosmic radiation, which can damage cells and DNA. Studies in this area are enhancing our knowledge of radiation protection and are vital for developing treatments for radiation exposure, whether from medical procedures or environmental sources. Here's a captivating insight into the study of circadian rhythms in space. Without a natural day-night cycle, astronauts rely on artificial lighting to regulate their sleep-wake patterns. This research is informing the design of lighting systems that promote healthy sleep, both in space and on Earth, benefiting shift workers and those with sleep disorders. Turning our attention to cardiovascular health once more, let's examine the effects of fluid redistribution in space. This shift can lead to increased pressure on the heart and blood vessels. By understanding these changes, scientists are developing new strategies for managing blood pressure and preventing cardiovascular events, which could improve heart health worldwide. Finally, think about the impact of space travel on respiratory function. The microgravity environment can alter lung volumes and breathing patterns. By studying these effects, researchers are gaining insights into respiratory health that could enhance treatments for asthma, chronic obstructive pulmonary disease, and other respiratory conditions. As we've explored these surprising facets of space medicine, it's clear that the challenges faced in space are driving innovations that extend far beyond the confines of our planet. Through this exploration, we're reminded of the incredible resilience of the human body and the limitless potential of scientific discovery, all inspired by our quest to understand and thrive in the cosmos. Let me share something intriguing about the effects of space travel on the human immune system. Did you know that in the microgravity environment of space, the immune system can become dysregulated? This means that astronauts may have altered immune responses, making them more susceptible to infections. This research is not only crucial for keeping astronauts healthy during missions, but is also shedding light on immune disorders here on Earth, paving the way for potential treatments and prevention strategies. Speaking of unique adaptations, consider how space travel impacts bone density. In the absence of gravity, astronauts can lose bone mass at a rate much faster than on Earth, akin to the effects of osteoporosis. This discovery is leading to new insights into bone health and the development of treatments that could help millions who are at risk of fractures and bone loss. Now, here's a captivating thought: the study of plant growth in space. Without gravity, plants grow differently, and scientists are observing how they adapt. This research holds potential for improving agricultural practices on Earth, especially in challenging environments, and could even pave the way for growing food on other planets. Have you ever pondered how the sense of taste might change in space? Interestingly, many astronauts report a decrease in their sense of taste, likely due to fluid shifts that affect the nasal passages. Understanding these changes is helping improve the taste and nutrition of space food, and it also offers insights into taste disorders and how they might be managed on Earth. Another remarkable area of study is the psychological resilience of astronauts. The extreme conditions of space travel provide a unique setting to study mental health and coping strategies. This research is invaluable for developing mental health support systems not only for astronauts, but also for individuals dealing with high-stress environments on Earth. On a tactile note, let's explore how the sense of touch is affected in microgravity. Without the constant pull of gravity, astronauts experience changes in their tactile perception. This has fascinating implications for haptic technology and the development of devices that could assist those with sensory processing disorders. Here's a thought-provoking concept: the impact of space travel on cellular senescence, which is the process by which cells cease to divide. Microgravity appears to accelerate this process, potentially influencing aging research. By studying these changes, scientists are exploring new avenues for anti-aging interventions and longevity research. Speaking of time, imagine the role of space travel in understanding time perception. In microgravity, the way we perceive time can change, offering a unique perspective on how the brain processes time. This research could lead to breakthroughs in understanding neurological conditions that affect time perception, such as Parkinson's disease. Turning to a more technical realm, there's the study of muscle atrophy in space. Astronauts experience significant muscle loss due to the lack of gravity's resistance. This phenomenon is driving innovations in exercise equipment and rehabilitation strategies, which could greatly benefit individuals recovering from injuries or dealing with muscle-wasting conditions. Another compelling topic is the use of microgravity to study fluid dynamics. Without gravity, fluids behave differently, leading to potential innovations in microfluidics and the development of advanced medical diagnostic tools such as lab-on-a-chip devices that could revolutionize healthcare diagnostics. Have you considered the impact of space travel on the vestibular system, specifically related to motion sickness? By understanding how the inner ear adapts to the lack of gravity, researchers are developing more effective treatments for motion sickness on Earth, which could help those who suffer from it during travel. And here's something fascinating about the study of microbial life in space. Microgravity affects the growth and behavior of microbes, which can influence how infections develop. This research is crucial for ensuring astronauts' safety and is also advancing our understanding of antibiotic resistance and infection control on Earth. Let me share something about the intriguing concept of cellular mechanosensitivity in space. Cells in the body respond to mechanical forces, and in the microgravity environment, these responses are altered. This research has implications for tissue engineering and regenerative medicine, potentially leading to new treatments for repairing damaged tissues. Speaking of cellular processes, consider the effects of space travel on oxidative stress levels. In space, the body's antioxidant defenses can be compromised, leading to increased oxidative stress. This understanding is vital for developing antioxidant therapies that could mitigate these effects, benefiting conditions that are influenced by oxidative damage, such as neurodegenerative diseases. Finally, ponder the potential of space travel in advancing telemedicine. The need to provide healthcare remotely during space missions is driving innovations in telehealth technology. These advancements are enhancing access to medical care on Earth, especially in remote or underserved areas, making healthcare more accessible to those in need. As we reflect on these surprising aspects of space medicine, it's amazing to see how the challenges of space not only expand our scientific horizons, but also enrich our lives here on Earth, inspiring a new era of healthcare and human resilience. The microgravity environment gives scientists an exceptional chance to observe changes at a genetic level, including gene expression and mutation rates. This research is unlocking secrets about how genes may regulate in response to different environments, offering insights that could lead to new genetic therapies for diseases on Earth. Here's a captivating detail. Space travel affects circadian rhythms, the body's internal clock that regulates sleep and wake cycles. Without the usual day-night cues, astronauts often experience disrupted sleep patterns. Understanding these changes is helping researchers develop therapies for sleep disorders, potentially aiding those who struggle with irregular sleep on Earth. Did you know that space travel can influence cardiovascular health? In microgravity, fluids shift towards the upper body, sometimes leading to increased intracranial pressure and affecting the heart's function. This phenomenon is providing valuable information on cardiovascular diseases and could guide the creation of interventions to prevent conditions like hypertension. Now, consider the fascinating study of wound healing in space. It's been observed that wounds may heal differently in microgravity, with cellular processes such as tissue repair and inflammation responding in unique ways. This discovery is paving the way for advanced wound care treatments, potentially benefiting those with chronic wounds or healing issues here on Earth. Another intriguing aspect is the impact of space radiation on human health. Unlike on Earth, where the atmosphere provides protection, astronauts are exposed to higher levels of radiation, which can damage DNA and increase cancer risks. This has led to innovative research focused on radiation shielding technologies and therapies that could also protect cancer patients undergoing radiation treatment. Let me share something curious about how space travel may affect insulin resistance. Microgravity seems to alter the body's metabolism, increasing the risk of conditions similar to diabetes. Studying these metabolic changes is helping researchers understand diabetes better and develop new strategies for managing blood sugar control. Have you ever thought about how space travel might impact vision? Some astronauts experience changes in vision due to fluid shifts affecting the eye's shape and pressure. This research is crucial in developing ways to protect vision during space missions and could lead to breakthroughs in treating vision problems like glaucoma on Earth. Speaking of senses, space travel also provides a unique opportunity to study the sense of smell. With fluid shifts altering nasal passages, astronauts often report changes in olfactory perception. This fascinating field of study has implications for understanding and managing anosmia, or loss of sense of smell, which affects many people globally. Moving on, the study of gut microbiota in space is another area rich with potential. The unique environment of space can alter the balance and function of gut bacteria, which play a crucial role in health and immunity. Research in this area is informing new ways to maintain gut health, which is essential for overall well-being both in space and on Earth. And here's a thought-provoking idea: the exploration of space travel's impact on reproductive health. While still in the early stages, studies suggest that microgravity might influence fertility and reproductive processes. This research is vital as we look toward long-term space missions and is also shedding light on reproductive health issues faced on Earth. Have you ever pondered the potential for space travel to assist in pain management? The unique conditions of space provide a platform to study pain perception and response, leading to new insights into chronic pain conditions. This research could revolutionize pain management therapies, offering relief to those who suffer from persistent pain. Now, picture the study of cognitive function in space. The extreme conditions of space travel can impact cognitive abilities, such as memory and attention. By understanding these effects, researchers are developing strategies to protect and enhance cognitive health, potentially benefiting those with neurological disorders or age-related cognitive decline. Speaking of age, there's an intriguing connection between space travel and telomere length. Telomeres, which protect the ends of chromosomes, appear to change in length during space missions. This research could provide clues to the aging process and inspire new anti-aging therapies that extend healthy lifespan on Earth. Lastly, consider the role of space travel in advancing surgical techniques. The challenges of performing surgery in microgravity are spurring innovations in robotic surgery and teleoperated systems. These advancements are improving precision and outcomes in surgeries on Earth, making them less invasive and more effective. Reflecting on these surprising facets of space medicine, it's clear that the exploration of space is not just about reaching the stars. It's about discovering new pathways to improve health and well-being for everyone. The insights gained from space research are transforming medicine on Earth, fostering innovation and inspiring a brighter future for human health. Let's continue exploring the fascinating world of space medicine with a thought-provoking question: how does space travel affect bone health? In the absence of gravity, astronauts experience bone density loss at a rate much faster than on Earth, akin to accelerated osteoporosis. This remarkable finding is providing critical insights into bone health and developing treatments to combat bone density loss, not just for astronauts, but for individuals with osteoporosis on Earth. And here's something intriguing: the phenomenon of space-induced anemia. It's been observed that the microgravity environment can lead to a reduction in red blood cell production, a condition known as space anemia. This has sparked new avenues of research into anemia treatments, offering hope to those who suffer from the condition here on Earth. Speaking of cellular changes, have you considered how cells communicate differently in space? The microgravity environment affects cellular signaling pathways, altering how cells send and receive messages. This discovery is paving the way for innovative therapies that target cellular communication, potentially leading to breakthroughs in treating diseases where cell signaling goes awry, like cancer or autoimmune disorders. Another captivating aspect of space medicine is the investigation into muscle atrophy. In space, the lack of weight-bearing activity causes muscles to weaken and shrink. This research is critical not only for preparing astronauts for long-duration missions, but also for developing new treatments for muscle-wasting diseases such as muscular dystrophy. Now, let's delve into the intriguing realm of immune system function in space. Did you know that astronauts' immune systems can become compromised during space missions? This vulnerability has spurred research into immune-boosting strategies, which could help enhance immune responses for those with weakened immune systems on Earth, like the elderly or individuals undergoing chemotherapy. Moving on. Another area ripe for exploration is the study of space-induced oxidative stress. In microgravity, cells seem to produce more reactive oxygen species, which can lead to oxidative damage. Understanding this process is crucial for developing antioxidant therapies that may protect astronauts from cellular damage and could also benefit people with conditions linked to oxidative stress, like Alzheimer's disease. Have you ever wondered how space travel might impact hormone regulation? The absence of gravity appears to influence hormone levels, including those related to stress and metabolism. This research is laying the groundwork for new approaches to managing hormonal imbalances and stress-related conditions here on Earth. Consider the unique challenge of dental health in space. With changes in bone density and fluid shifts, astronauts' dental health can be affected, leading to innovative research into preventive oral care and treatment methods that could improve dental health for people on Earth. Furthermore, the study of space medicine includes the fascinating potential for tissue regeneration. In microgravity, some tissues may regenerate more rapidly, offering exciting possibilities for regenerative medicine techniques that could heal injuries and replace damaged tissues efficiently. Can you imagine the potential for space travel to unlock secrets of stem cell behavior? Research suggests that microgravity influences stem cell growth and differentiation. This knowledge could revolutionize regenerative medicine by enhancing the ability to grow and use stem cells to repair damaged organs and tissues. And speaking of regeneration, the unique conditions of space are also being used to study the potential for heart repair. Scientists are investigating how heart cells behave in microgravity, with the hope of developing new therapies for heart disease, which remains the leading cause of death worldwide. Now, let's turn our attention to the fascinating world of nutrient metabolism in space. The lack of gravity alters how the body absorbs and uses nutrients, providing valuable insights into nutrition and dietary requirements. This research is crucial for ensuring astronauts remain healthy during missions and could also inform dietary guidelines to combat malnutrition and obesity on Earth. Another captivating topic is the impact of space travel on skin health. The conditions of space can lead to changes in skin thickness and elasticity. Studying these changes is guiding the development of advanced skincare treatments that could help maintain healthy skin for both astronauts and those on Earth facing skin conditions such as psoriasis or eczema. Let me share a surprising fact about how space travel influences lung function. In microgravity, the distribution of air in the lungs changes, affecting how efficiently they work. This research is instrumental in understanding lung diseases and could lead to more effective treatments for conditions like asthma and chronic obstructive pulmonary disease. Lastly, let's not forget the potential for space travel to advance antibiotic research. The unique environment of space can alter bacterial growth and resistance patterns, offering a new perspective on antibiotic development. This research is critical in the fight against antibiotic-resistant bacteria, a growing concern in global health. Reflecting on these incredible discoveries, it's evident that space medicine is more than just preparing humans for life beyond Earth. It's about harnessing the unique conditions of space to drive medical innovations that can transform healthcare on our planet. With each revelation, we're not only expanding our horizons, but also deepening our understanding of human health, leading to a future where medicine is more personalized, effective, and accessible for all. Let me take you on a journey to explore the fascinating intersection of space travel and mental health. You might wonder how the isolation and confinement of space missions affect astronauts psychologically. This environment presents an opportunity to study resilience and mental health strategies that can be applied to people experiencing isolation on Earth, such as individuals in remote locations or those quarantined due to health concerns. Interestingly, research has shown that certain brain functions adapt to the sensory and cognitive demands of space, offering insights into neuroplasticity, the brain's ability to reorganize itself, which could inform treatments for brain injuries. Speaking of the brain, have you ever considered how microgravity might influence sleep patterns? Astronauts often experience disruptions in their circadian rhythms due to the absence of a natural day-night cycle. Studying these changes helps scientists understand sleep disorders and develop better treatments to support those suffering from insomnia or shift work sleep disorder. It's quite remarkable how insights from space can guide improvements in sleep quality for people here on Earth. Now, let's shift our focus to the study of balance and coordination in microgravity. Without the usual gravitational cues, astronauts rely more heavily on visual inputs to maintain balance, providing a unique perspective on how the body compensates for sensory loss. This research has the potential to assist individuals with balance disorders or those recovering from inner ear surgeries by developing therapies that enhance their stability and coordination. Did you know that the microgravity environment also influences how we perceive taste and smell? Many astronauts report changes in their taste preferences while in space, often gravitating towards spicy or stronger flavors. Understanding these sensory shifts could lead to the development of personalized nutrition plans for individuals with altered taste perception, such as cancer patients undergoing chemotherapy. Speaking of nutrition, the challenges of food storage in space have sparked innovation in food preservation technologies. The need for lightweight, long-lasting and nutritious food options has led to advancements that might one day benefit food security on Earth, especially in regions where food preservation is essential due to limited access to fresh produce. Have you ever thought about how space travel could impact wound healing? In microgravity, the way wounds close and heal can be different from on Earth. This ongoing research may unlock new methods to enhance wound healing processes, potentially leading to faster recovery times for patients after surgeries or injuries. Here's a truly intriguing aspect: how space medicine is contributing to the study of radiation exposure. Beyond Earth's protective atmosphere, astronauts are exposed to higher levels of cosmic radiation, which is being studied to develop better shielding techniques and medical protocols. These insights are crucial not only for protecting future space travelers, but also for improving radiation safety protocols for medical workers and patients undergoing radiation therapy. Considering the potential threats of space radiation brings us to another concern: the study of cancer risk. Space medicine research delves into understanding how exposure to radiation and microgravity might influence cancer development. This research has profound implications for cancer prevention and treatment on Earth, as it could lead to new strategies that minimize cancer risks for populations exposed to high radiation levels. Transitioning to a lighter topic, let's explore how space medicine is shedding light on bone healing. Scientists are studying how bones regenerate in microgravity to better understand the mechanisms of bone repair. This could revolutionize orthopedic treatments, especially for fractures and bone diseases, by identifying ways to accelerate bone healing or improve bone density. Speaking of bones, did you know that space medicine research has provided insights into joint health? The stress-free environment of space affects joint lubrication and cartilage preservation. This knowledge is guiding the development of innovative treatments for joint conditions like arthritis, aiming to enhance joint mobility and reduce pain. Another surprising fact involves the study of kidney function in space. Microgravity affects how the body processes and excretes waste, offering a unique perspective on kidney health. This research may lead to better management of kidney diseases and improved dialysis treatment, benefiting patients worldwide. As we continue exploring, consider the role of space medicine in understanding cognitive performance. The unique demands of space travel require astronauts to maintain high levels of cognitive function. Studying how cognitive abilities are affected by space conditions can provide valuable insights into neurodegenerative diseases, potentially leading to interventions that enhance cognitive health in aging populations. Reflecting on these astonishing discoveries, it becomes evident that space medicine is not confined to the realm of preparing for life beyond our planet. Instead, it serves as a beacon of innovation, illuminating pathways to improved health and well-being for all of us. With each remarkable finding, we are not only pushing the boundaries of human knowledge, but also paving the way for a future where healthcare is more advanced, personalized, and accessible to everyone. Let me share something intriguing. Research into space medicine has revealed that astronauts experience a reduction in blood volume while in space. This occurs because microgravity causes fluid shifts towards the upper body, which can lead to a decrease in the amount of circulating blood. This phenomenon is not just a curiosity of space travel. It provides valuable insights into managing conditions like orthostatic intolerance, where patients experience dizziness or fainting upon standing due to a sudden drop in blood pressure. You might be surprised to learn how space travel impacts the immune system. In the microgravity environment, astronauts' immune responses can become less effective, making them more susceptible to infections. Understanding these changes is crucial for developing strategies to bolster immune function, which can be particularly beneficial for individuals with compromised immune systems on Earth. Here's something interesting about biological rhythms in space. The absence of a natural day-night cycle affects not only sleep patterns but also hormone levels, such as cortisol, which plays a key role in stress responses. Studying these variations helps scientists develop better methods to manage stress and improve mental health in those whose daily routines are disrupted, like shift workers or frequent travelers. Did you know that space medicine has also provided insights into muscle atrophy? In microgravity, muscles can weaken rapidly without the need for constant use against gravity. This research is pivotal in developing countermeasures for muscle-wasting diseases and conditions that lead to prolonged bed rest, helping patients to maintain muscle mass and strength during recovery. Speaking of muscles, the heart is another organ affected by space travel. the heart muscle can become smaller and less efficient at pumping blood in microgravity, a condition that scientists are studying to better understand heart failure on Earth. This knowledge could lead to innovative treatments that improve cardiac function and patient outcomes. Let me share another captivating fact. The study of fluid distribution in space has provided insights into eye health. Some astronauts experience changes in vision due to increased pressure on the eyes from fluid shifts, a condition known as spaceflight-associated neuroocular syndrome. This research could revolutionize eye care, leading to new treatments for conditions like glaucoma or ocular hypertension. Can you imagine how space medicine is advancing our understanding of genetics? The stresses of space travel, including radiation and microgravity, can lead to genetic mutations. By studying these changes, scientists are gaining insights into how genetic stability is maintained, potentially leading to breakthroughs in cancer research and genetic disorders. Here's a fascinating fact. The study of the vestibular system in microgravity offers unique insights into motion sickness. Many astronauts experience space motion sickness as their bodies adapt to the new gravitational environment. Understanding these mechanisms can help develop better treatments for motion sickness on Earth, enhancing the quality of life for those who suffer from it during travel. Speaking of adaptations, did you know that microgravity affects how the body regulates temperature? The body's natural cooling processes, such as sweating, can be altered in space, providing a better understanding of thermoregulation. This research could lead to improved strategies for managing heat-related illnesses, especially in hot climates or for athletes and outdoor workers. This reminds me of the fascinating work being done on red blood cell production. In space, changes in red blood cell levels are observed due to altered production rates. Studying these shifts can offer insights into managing anemia and other blood disorders on Earth, potentially leading to new therapeutic approaches to boost red blood cell counts. Turning to the topic of metabolism, space travel has shown us that microgravity can influence metabolic processes, including the breakdown of nutrients. This has implications for understanding metabolic disorders like diabetes and obesity, as insights from space can help develop more effective dietary and pharmaceutical interventions. Did you ever wonder how space medicine contributes to our knowledge of skin health? In microgravity, changes in skin hydration and elasticity have been observed, offering a unique perspective on how skin ages and repairs itself. This research could pave the way for better skincare treatments, especially for conditions like eczema or psoriasis. And here's something that might surprise you. The study of microbial life on spacecraft has led to discoveries about bacterial behavior. Some bacteria can become more virulent in space, which is helping researchers understand infection mechanisms and develop robust antimicrobial strategies that are vital for both astronauts and patients on Earth. Consider how space missions provide opportunities to study psychological resilience. The isolation and confinement of space travel require astronauts to manage stress and maintain mental well-being, offering valuable lessons in resilience that can be applied during crises or in high-stress occupations here on Earth. Finally, let's reflect on how the study of human adaptation to space is informing prosthetics development. Understanding how the body compensates for the challenges of microgravity provides insights that can lead to more effective prosthetic limbs, improving mobility and quality of life for amputees. Each of these insights highlights the profound impact that space medicine research has on advancing our understanding of human health, both in the extraordinary environment of space and in everyday life on Earth. Through this continuous journey of discovery, we find ourselves not only exploring the cosmos, but also unveiling new possibilities for enhancing human well-being. Let me share something intriguing about the impact of space travel on bone health. In microgravity, astronauts can lose bone density at an alarming rate, sometimes equating to 1 to 2% per month. This accelerated bone loss is comparable to osteoporosis, but happens much more quickly. By studying the underlying mechanisms, researchers are gaining valuable insights into bone density maintenance, which could lead to enhanced treatments for osteoporosis on Earth. Speaking of bones, did you know that the absence of gravity affects calcium metabolism? In space, the balance of calcium in the body shifts, leading to an increase in calcium excretion. This phenomenon helps scientists understand calcium-related disorders, such as kidney stones, and could guide the development of better prevention and treatment strategies. Another captivating area of research focuses on the effects of radiation exposure in space. The cosmic radiation encountered by astronauts is much higher than on Earth and poses risks of cancer and damage to bodily tissues. By studying these effects, scientists are working on protective measures, not only for space travelers, but also for improving radiation therapy and cancer treatment. Here's a fascinating fact. The study of cardiovascular health in space has unveiled surprising insights into blood pressure regulation. In microgravity, blood tends to distribute more evenly across the body. Understanding these changes can help develop new treatments for hypertension and other cardiovascular conditions. Did you ever wonder how the body's circadian rhythms adapt to space? Without the usual day-night cycle, astronauts rely on artificial lighting to regulate their internal clocks. This research is critical for improving sleep quality and managing circadian rhythm disorders in people who work night shifts or experience jet lag. This reminds me of the remarkable findings regarding immune cell function in space. Astronauts often experience altered immune responses, with some immune cells becoming less effective, while others might become hyperactive. Analyzing these changes is helping scientists to devise strategies to modulate immune function, which could be especially beneficial for autoimmune diseases. Speaking of immune function, did you know that spaceflight can influence the gut microbiome? The unique environment affects the balance of bacteria in the digestive system, offering insights into how gut health influences overall immunity. This knowledge could lead to novel probiotics or dietary recommendations to enhance gut health. Let's explore another surprising fact about space travel and mental health. The confined and isolated nature of space missions can impact psychological well-being, prompting the development of innovative support systems and therapies. These interventions could prove invaluable in extreme environments or for individuals experiencing similar conditions on Earth. You might be interested to learn about how muscle protein synthesis changes in space. In the absence of gravity, muscles can lose mass and strength rapidly. By understanding these biochemical processes, researchers are paving the way for therapies that could prevent muscle wasting in various medical conditions. Speaking of which, the study of metabolic changes in space reveals how energy expenditure can differ. Astronauts often experience a decrease in basal metabolic rate, which has implications for understanding weight management and metabolic diseases. This research could inform more effective strategies for obesity and metabolic syndrome. Consider this intriguing insight. Space research has also expanded our understanding of wound healing. In microgravity, the processes that underpin tissue repair and regeneration can differ from those on Earth. This knowledge is crucial for developing treatments that enhance healing in patients with chronic wounds. Building on this, did you know that space medicine has contributed to our understanding of drug efficacy? The altered physiological conditions in space can affect how drugs are absorbed and metabolized, leading to innovations in personalized medicine and drug delivery systems. Here's another amazing fact. The study of balance and coordination in microgravity has shed light on motor neuron functions. Space research is helping to unravel how the brain and body communicate to maintain balance, which could lead to improved therapies for neurological disorders affecting mobility. As we delve further into the wonders of space medicine, think about how fluid shifts in microgravity inform our understanding of intracranial pressure. Some astronauts experience increased pressure inside the skull, which is being studied to improve treatments for conditions like hydrocephalus on Earth. Finally, let's consider the effects of space travel on reproductive health. While not fully explored, the implications of microgravity on reproductive functions are significant, with potential impacts on fertility and development. This research could lead to breakthroughs in reproductive medicine, offering hope for those facing challenges in this area. Isn't it extraordinary how much we learn from the vastness of space? Each discovery not only pushes the boundaries of what we know about human health in the cosmos, but also brings transformative benefits to life here on Earth. These insights continue to inspire awe and reflect the incredible potential of space medicine research. Speaking of the vastness of space, let's ponder the intriguing relationship between space travel and human vision. Did you know that some astronauts experience changes in their vision after long periods in microgravity? This condition, known as spaceflight-associated neuroocular syndrome, or SANS, involves changes in the shape of the eye and increased pressure on the optic nerve. Researchers are keenly exploring this phenomenon to better understand how fluid shifts in the body affect eye health. Insights gained might lead to new approaches in treating vision-related issues on Earth. Now, imagine the challenges of conducting surgery in space. The microgravity environment complicates even basic medical procedures. Scientists are developing innovative surgical techniques and instruments to ensure astronauts can receive emergency care when needed. These advancements are not only essential for future space missions, but also inspire new methods and tools that could enhance surgical precision here on Earth. Consider this. The study of space travel has even touched on the peculiar subject of smell. Due to changes in blood flow and congestion in the nasal passages, the sense of smell can be dulled in space. This has prompted research into how smell and taste interact and how they can be enhanced, potentially leading to better flavor experiences for people with impaired senses. Did you ever wonder how plants might grow in space? Understanding plant biology in microgravity is vital for long-term missions, as plants can provide both food and oxygen. Experiments on plants like wheat and lettuce have shown that while growth patterns differ, these essential crops can adapt to the unique environment. This research is not just for space, it also contributes to agricultural advancements under challenging conditions on Earth. And here's something truly fascinating. Space medicine research is shedding light on the concept of hibernation, or more accurately, torpor. Scientists are exploring whether inducing a state of torpor in astronauts could be beneficial for long-duration space travel. This research holds promise not only for space missions, but also for therapeutic hypothermia treatments, which can help in medical situations such as stroke or cardiac arrest. Speaking of adaptation, you might find it interesting to learn about how space travel affects the vestibular system, the part of our inner ear that helps maintain balance. Without gravity, the signals to the brain about orientation and movement can become confusing, leading to space adaptation syndrome, or what's commonly known as space sickness. Studying these effects, is helping to develop countermeasures that improve astronauts' comfort and performance in space, as well as treatments for balance disorders on Earth. Here's a curious insight: the investigation of how space travel impacts dental health. The lack of gravity means that the act of chewing and swallowing changes, leading researchers to study saliva production and its protective role in oral health. This area of research may develop new strategies for oral hygiene and treatments for dry mouth conditions. Another captivating facet is the use of virtual reality in space medicine. With the isolation and confinement of space travel, maintaining mental health is crucial. Virtual reality is being tested as a tool for relaxation and cognitive engagement, providing a much-needed mental escape and helping to combat stress and loneliness. This technology has potential applications in treating anxiety and depression on Earth, offering immersive experiences that promote emotional well-being. Just think about how the isolation of space has led to a deeper understanding of social dynamics and teamwork. The confined living arrangements in space missions require effective communication and conflict resolution skills. Studies on these dynamics are not only invaluable for future missions to distant planets, but also enhance our understanding of team performance and leadership, applicable in various fields back on Earth. Then there's the impact of space on blood clotting processes. Microgravity affects how blood circulates, raising questions about the risk of clot formation. Research in this area is leading to a better understanding of blood clotting mechanisms, which could revolutionize treatments for patients at risk of thrombosis or embolism. Have you ever thought about how space travel might influence hair growth? Some astronauts report changes in hair growth patterns during and after missions. This intriguing observation is prompting studies into the biological factors controlling hair growth, potentially offering insights into hair loss treatments. Speaking of body processes, the study of metabolic wastes in space is providing unique perspectives on kidney function. The elimination of waste products is altered in microgravity, leading to innovative research that could improve the management of kidney-related diseases. Lastly, let's consider the intriguing concept of how space travel might affect aging. Some studies suggest that the cellular stress of microgravity could accelerate certain aspects of aging, while others might slow down. By understanding these processes, scientists hope to uncover new strategies for promoting healthy aging, extending the potential benefits far beyond the boundaries of our planet. Isn't it remarkable how space medicine research opens up so many unexpected avenues of exploration? Each revelation brings us closer to understanding the intricate tapestry of human health, both in the stars and on Earth. The quest to explore the final frontier continues to inspire awe and wonder as we unravel the mysteries of life in space and their profound impact on our journey through existence. Let me share something intriguing. The study of space medicine has delved into the effects of cosmic radiation on the human body. Cosmic rays pose a significant risk to astronauts, as they can damage DNA and increase cancer risk. By studying how radiation interacts with human cells in space, scientists are developing better protective measures and treatments that could also benefit radiation therapy patients on Earth. Did you know that bone health is another critical concern for astronauts? In the absence of gravity, bones can lose density at a much faster rate than on Earth, sometimes up to 1% per month. This research is guiding the development of new treatments for osteoporosis and other bone-related conditions, helping people maintain bone health as they age. Speaking of skeletal health, muscle atrophy is yet another challenge faced during space travel. The reduced need for muscle exertion in microgravity leads to muscle weakening and loss. To counteract this, astronauts perform specific exercise routines in space. The insights gained from these studies are being used to design better rehabilitation programs for muscle loss due to aging or illness here on Earth. Here's a fascinating fact. Microgravity affects the cardiovascular system in ways that are both complex and enlightening. With less gravitational pull, blood and fluids tend to rise to the upper body, altering heart function and blood pressure regulation. By understanding these changes, researchers are developing new ways to manage heart health and fluid balance, which could improve treatments for heart diseases and conditions like hypertension. Consider this. The psychological effects of long-duration space missions are being closely examined to support astronauts' mental well-being. The unique stresses of space travel, such as isolation and confinement, offer insights into how humans cope with extreme environments. This knowledge is not only enhancing astronaut support systems, but also contributing to mental health strategies for remote or high-stress work environments on Earth. And here's something surprising. Studies are exploring how microgravity impacts the immune system. Space travel appears to weaken immune responses, making astronauts more susceptible to infections. This research is revealing crucial information about immune function, which may lead to new ways to strengthen immunity in both astronauts and people with weakened immune systems on Earth. You might find it interesting to learn about the influence of space on sleep patterns. The lack of a natural day-night cycle in space can disrupt circadian rhythms, leading to sleep disturbances. By investigating these effects, scientists are developing novel approaches to manage sleep disorders, which could help those suffering from insomnia or shift work-related issues. Speaking of sleep, did you ever wonder how space travel affects skin health? The unique environment beyond our planet alters skin hydration and elasticity. This research is helping to create advanced skincare products and treatments that could benefit people with skin conditions or those exposed to harsh environments. Here's something curious. The study of space medicine is uncovering the impact of microgravity on gut health. Changes in diet and fluid distribution affect digestion and gut bacteria balance. Understanding these alterations is key to developing probiotics and nutritional strategies that support digestive health, both in space and for those with gastrointestinal disorders on Earth. Another captivating facet of space medicine is the research into how space travel might influence reproductive health. While this area is still in its early stages, preliminary studies on how microgravity and radiation may affect fertility and development are underway. These findings could enrich our understanding of reproductive biology and inform safer space travel protocols for future missions that may include families. Let's also consider how the unique conditions of space are aiding in the study of cancer. Cancer cells behave differently in microgravity, providing a novel perspective on tumor growth and metastasis. This research is paving the way for new cancer treatments and could lead to breakthroughs in how we understand and combat this complex disease. Did you ever think about how space medicine research is contributing to the development of advanced telemedicine technologies? With astronauts far from traditional medical facilities, reliable remote health monitoring and diagnostic tools are essential. The innovations from this research are improving telehealth services on Earth, making healthcare more accessible for those in remote or underserved areas. Here's an unexpected insight. Space travel's impact on vision is shedding light on eye pressure and vision changes, known as spaceflight-associated neuroocular syndrome. By studying these effects, scientists are gaining valuable knowledge that may improve the management of eye conditions related to fluid pressure on Earth. And finally, Let's reflect on the potential of artificial intelligence in space medicine. AI is being used to analyze vast amounts of health data collected from astronauts, helping to predict medical issues and tailor individual treatments. These advancements in AI are enhancing personalized medicine, offering more precise and effective healthcare solutions for people everywhere. Isn't it remarkable how the exploration of space medicine continues to expand our understanding of human health in unexpected ways? Each discovery brings not only immediate benefits for space exploration, but also profound implications for improving life on our own planet. As we continue to reach for the stars, the knowledge we gain illuminates new paths for healing and innovation, enriching our collective journey. Here's a fact that might surprise you. In the microgravity environment of space, wounds tend to heal differently. The lack of gravity affects the way cells move and interact, which could inform new methods for wound treatment and healing here on Earth. This research is especially promising for individuals with chronic wounds, like those caused by diabetes or poor circulation. Now, let's consider the impact of space travel on allergies. Interestingly, astronauts sometimes develop allergies to substances they were previously tolerant to after spending time in space. By studying these shifts, scientists are uncovering new aspects of immune regulation that might help manage allergic reactions and autoimmune disorders more effectively. Have you ever thought about how space affects nutritional needs? Without the force of gravity, food behaves differently, and astronauts may experience changes in appetite or nutrient absorption. This research is leading to the development of specialized diets and supplements that ensure optimal nutrition during long voyages, which could also improve nutritional interventions for malnourishment or dietary restrictions on Earth. Speaking of nutrition, did you know that certain plants grown in space show enhanced levels of vitamins and nutrients? The absence of gravity seems to influence plant metabolism in unique ways. This could lead to breakthroughs in agricultural practices and food security, providing more resilient crops that thrive in challenging environments. Let's talk about something intriguing: the study of stem cells in space. Without gravity, stem cells grow and differentiate differently, offering a unique window into their behavior. This research is revealing potential new ways to harness stem cells for regenerative medicine, which could revolutionize how we treat injuries and degenerative diseases. On a different note, space travel is also helping us understand balance and coordination. In microgravity, the vestibular system, which controls balance, operates differently, leading to disorientation and dizziness. These findings are aiding in the development of therapies for balance disorders and vertigo on Earth, enhancing quality of life for those affected. It's fascinating to think about how microgravity affects kidney function too. The kidney's ability to filter blood and regulate electrolytes is altered in space, which is providing insights into kidney disease and the management of fluid and electrolyte balance. This research might lead to better treatments for people with kidney conditions. Another captivating aspect is the role of space medicine in studying bone marrow function. The production of blood cells in microgravity is different, which could help us better understand and treat blood disorders. This knowledge is particularly valuable for developing therapies for conditions like anemia or bone marrow failure. Have you ever considered how space travel might impact the aging process? Some studies suggest that certain aspects of aging, such as muscle atrophy and bone density loss, occur more rapidly in space. By examining these changes, scientists are gaining insights into the biological mechanisms of aging, which could lead to interventions that promote healthy aging on Earth. In a similar vein, space medicine is shedding light on the body's stress response. The unique stresses of space travel, including radiation exposure and isolation, activate stress pathways in novel ways. Understanding these responses is helping to develop better stress management strategies for both astronauts and individuals dealing with chronic stress or anxiety. Did you know that studying the effects of radiation in space is crucial for understanding its impact on human health? Space radiation is much higher than what we experience on Earth, providing a unique opportunity to study its effects on the body. This research is informing new strategies for radiation protection, which could benefit cancer patients undergoing radiation therapy. Here's something curious. The exploration of space is also driving innovations in surgical techniques. Surgeons are developing procedures that can be performed in microgravity, leading to advancements that could improve minimally invasive surgeries on Earth, making them safer and more effective. Let's also reflect on how space medicine is contributing to our understanding of chronic pain. The changes in muscle and bone experienced in microgravity can alter pain perception, offering insights into the mechanisms of chronic pain. This research is paving the way for novel pain management therapies that could provide relief to millions suffering from persistent pain. Another fascinating area is the study of the human microbiome in space. The balance of bacteria in the human body changes in microgravity, which might influence health and disease resistance. By exploring these changes, scientists are developing new probiotics and treatments that maintain healthy microbiomes, promoting overall wellness. Finally, let's consider the potential of space medicine to advance our understanding of sleep-related breathing disorders. In space, the distribution of fluids in the body can affect the airways, providing a natural model to study conditions like sleep apnea. Insights from this research are leading to better diagnostic tools and treatments for these common disorders. Isn't it amazing how the exploration of space continues to enhance our knowledge of human health in so many surprising ways? Each discovery not only holds the promise of safer and more effective space travel, but also transforms how we address health challenges here on Earth. The mysteries of space are not only about distant stars and planets, but also about unlocking the secrets of our own biology, offering hope and innovation for the future. As we journey onward, the wisdom we gather from beyond our planet enriches our understanding and touches lives in profound and meaningful ways.